Hello, I'm Robert Sumwalt. Today we are going to have a very exciting discussion about one of the most iconic civilian airliners, the Concorde. Concorde was first flown in 1969, and a few weeks later, at the controls, were my good friend, Jean Pinet. In fact, Jean was the very first pilot to take Concorde in excess of the speed of sound. So welcome, Jean Pinet. Jean, you and I have known each other for over 30 years, and I've always enjoyed being with you. You've got a fascinating aviation background. Tell us how you got started in aviation and where you progressed and how you ended up being one of 4 French test pilots to fly Concorde. In fact, you were the first pilot to exceed the speed of sound in Concorde. Tell us about it.
So it started a long time ago. When I was a student, it was during the Second World War, and I was passionate about seeing the evolution of aviation at that time. It was essentially military aircraft, and I was dreaming a little bit, seeing fighter jets in particular. Then I studied engineering at the Arts et Métiers. I was a civil aeronautical engineer with ERAU, and that's when I thought I could be something other than just a pilot. Because the risk was also something for me, a plus. I decided to become a test pilot. Well, so for that I joined the Air Force for 4 years. I became a fighter pilot. By the way, with my qualification obtained in the United States, with the US Air Force with Class 54P. Yes. Then I entered the French Flight Test Center, where I was a test navigator engineer and test pilot, the person in charge of air-to-air and air-to-ground missile tests. Then, in Germany, although with the same qualifications, I was responsible for the development of the missiles, precisely on the F-104G Starfighter, and it was then that André Turca, who was the director of flight tests at Sud Aviation and in charge of the Concorde program on the French side, was looking for a test rider who is an engineer with Mach 2 experience. There weren't many at the time, and he asked me in 1965 to join him for his Concorde's test in his team. So in fact, the first time when I met him, he explained the project to me, of which I have absolutely no information. So the project was so crazy, so out of the ordinary, that I immediately accepted the challenge for a young engineer, a young test pilot. For me, it was extraordinary. So I was in the Concorde program in 1965. The plane, the prototype was in the process of prototypes, because there was one in France and one in Great Britain that was being built. My work consisted with the design office to study, to develop a little bit all the equipment in all the possible and imaginable settings, so that the plane would be good for flight in all its flight domain. I was the person in charge, in fact, of flight handling qualities. And for 3 years, I was with the Aviation Tracking Design Office, responsible for flight simulator tests. And when the first flight arrived, so it was in 1969, it took place on March 2nd, and I had the privilege, after all of the great test pilot of the moment who showed up to see Concorde, I was the 7th pilot to fly on Concorde at the end of the month. On March 30th, 1969, that's it. So for me it was very important because I knew how the plane was going to behave, because I had studied it, I had even developed a simulator, but the simulator only had a visual, a very basic visualization. And when I was in the cockpit and I flew, there was tremendous visibility because there was nature itself in front of me. So my first thought was, it's like a simulator. So then there was this Mach 1 flight. obviously for transport, a civilian transport plane that is, past Mach 1 was something very symbolic. It's the first time it's happened. It was still a challenge that was much more important than just a symbol. It was about the very existence of the project. Could the plane carry out the mission of crossing the Atlantic between Paris or London and New York? This was the mission for which it had been constructed. And in fact, the exact question was, would the aerodynamic drag be in line with the forecasts, or would it be greater than with the forecasts? What if it was more important than the forecast? It is certain that the project was still born. So, by the way, switching to supersonic, now I have my little model, not this, when moving to supersonic, so there's a shock zones that come everywhere around the aircraft, and obviously it changes the aerodynamic configuration considerably. In particular, one point. This is the center of aerodynamic pressure on the aircraft. In other words, the aerodynamic result of all the efforts. So when normally in subsonic, let's say it shows up there, on the aircraft, the center of gravity is just forward. But when you pass Mach 1 with shock waves, the center of thrust goes backwards slightly. This causes the lever arm between the center of push and the center of gravity to increase, and the aircraft tends to nose down. To prevent it from swooping down at that moment, we steer the controls upwards in the nose-up attitude, right? But this steering is a very important source of aerodynamic drag, and this aerodynamic drag, we also had to know it. So the problem was to know where the center of aerodynamic thrust was going to be positioned. To do that, it was enough to see how the flight controls were going to behave, how the control surfaces were going to behave as the plane accelerated. And we could deduce from the movement of the flight controls where the center of thrust was going to be aerodynamic. And on top of that, we still had some doubts because all the wind tunnel tests showed that there was no problem. We had also done float tests. Even during this last subsonic flight, everything seemed normal, but we still like to have a confirmation of all of this to see if there was any dangerous phenomenon when passing Mach. Everything went really well. It was completely in line with expectations. So it is probably because I spent 3 years studying all these configurations that André Turcat did me the honor of flying the aircraft in this flight to confirm in the end that my efforts had not been in vain. We still had a lot of problems. Well, in fact, to go back to the previous question, we still had a lot of problems to solve. In particular, the flight envelope was an immense one, since it ranged from 0 to Mach 2.05, or in aerodynamic speed from 0 to 530 knots, and at altitude from 0 to 60,000 feet, with the center of gravity that also traveled according to the position of the aerodynamic center, which led to power relations on the control surfaces that went in factors greater than 10. But the problem is, it was around the right of the driver. So the driver had to do it. And to not notice all this, and for that it was necessary that all the points of the domain, the movement that gave the sticks in roll or pitch always corresponded to the same response of the aircraft, regardless of the effectiveness of the control surfaces. There was a lot of work to be done, and at the time we didn't have digital technology to help us. We only had analog, and it was a bit difficult. So another thing is that we discovered in the simulator, by the way, that there was a danger zone around Mach 1.15. It was an area where there was a pilot-aircraft coupling, leading to oscillations of the PIOs, or pilot in the oscillations, in rolls and yaws that could diverge in an irretrievable way. therefore very dangerous. So we had to find a solution. We found it, by the way, and then there was no problem. Another thing too, Concorde was the first civil aircraft to fly by wire. But there was always, it was the first time, there was the fly-by-wire. There were still classic manual flight controls with cables from the control column to the hydraulic cylinder of the control surfaces. It was also necessary for the pilots to be able to bring the plane back because it was still a backup solution without any problem. And that, I think, is one of the problems that has given us the most difficulty. In addition, I must say that in the entire operational life of the aircraft, there has not been a single flight where there has been this manual mechanical piloting. So the fly-by-wire was quite reliable. Then we had to define a centering corridor, since the center of thrust therefore varied with the number of Mach. Therefore the center of gravity also had to follow it. And in order for the center of gravity to follow it, we had fuel transfer from front to rear or from rear to front when we detected it, in order to always have the center of gravity in the right place. It was important because when we were at Mach 2, the position of the center of gravity was such that we could not land with this position of center of gravity because the plane was too unstable. So everything had to be perfectly reliable and work properly. And finally, as a last point, I could mention it's in the maximum incidences. The aircraft can go up to an incidence of about 20 degrees. Beyond this maximum incidence, there was a pitch up that was brutal and recoverable. So we also had to develop a whole series of protection and alarm protection in order not to reach this limit. And so all of this worked well, that's it.
I imagine flying Concorde for many, many flights. You've had some very interesting flights. Tell us about one or two of those. In fact, I remember you were telling us about one where you flew the then French president, Pompidou. Tell us about that one.
There are actually at least two flights that I have a completely indelible memory of. The first flight was, well, it was without passengers. It was a test flight. It was a flight at the beginning of the Mach 2 flights with the prototypes. It was January 1971. The plane had been supersonic Mach 2 since November, and we were doing performance tests. We were going to the Atlantic, Mach 2, and then we were coming back. And on the return flight, it must be said that the engines, they didn't have the power rate of the production engines, and they were still a little too weak to keep the Mach 2 on the prototype during the whole flight. And we were forced to put the warm-up, in other words, the reheat. So on this return from flight, we had the 4 engines with heaters, and my comrade, Gilbert de Ferrand, was on the left. I was on the right. In all the flights, there was alternation, either to the right or to the left. And that day, so I was on the right. We had to decelerate subsonically, so I had to turn off the heats. It was then, when I cut a heater, that there was a very strong pumping of an engine that reverberated on the second, which was adjacent. Because indeed, in the nacelle, if you see they're right next to each other, and one of their air inlet ramps was eliminated, ejected, we didn't know what was going on. We were shaken extraordinarily, and very quickly we saw that we had lost a piece of the air intake basket, and we returned to the field. It was very far away because it happened off the coast of Ireland, and we had to go back to Toulouse, France. The damage was very significant. We were happy to see that we survived this kind of thing. In fact, the problem was that there was an engine adjustment that didn't work, and it led to an air inlet pumping. That was the first incident. The second was with our President of the Republic, French Republic, Georges Pompidou, who was going to meet President Nixon in the Azores. and who had decided to go there with the Concorde, while Nixon went there with his Air Force One in Boeing 707. Now, the trip with the Concorde 001 was without difficulty, but at the time, we had a prototype that was not at all certified for blind approaches of the 4.2 or 4.3 type. So we were limited to 200 feet of ceiling and 500 meters of visibility. And when we left, we had been told that there was a risk of thunderstorms in Lares, in the Azores, and our diversion area was on the island of Santa Maria, which was 200 kilometers away, but which had no kerosene resources, so it was better to stay on Lares rather than divert. However, when we arrived inside of Lares, there was a huge cumulonimbus cloud on the island, and the tower still announced visibility of more than 500 meters and a ceiling of more than 200 feet. So Jean Franqui, who was on the left at the time, and I decided to continue, and then we'd see if we had to divert or not. It was better not to go astray. So we entered this kind of huge cumulonimbus cloud. We had two sources of information for the landing. We had an ILS, which was a completely classic ILS that was not at all certified for Category 2 or Category 3 approaches, but normal. And there was also a GCA position that had been set up by the American for Air Force One so that there would be no problem for their president. So we decided with Jean Franqui that he would take care of the GCA's information and I would take care of the ILS's. It was during the approach that we were subjected to a phenomenon that we did not know, but which had already killed several aircraft. It was the downdraft under the cumulonimbus clouds. We did not know that at all. So we had an extremely difficult approach, and we really landed just right at the limit. It's certain that if we hadn't had Concorde, if it had been an ordinary aircraft by, for example, Air Force One, we wouldn't have survived. We survived thanks to the extremely precise piloting of the aircraft and also to the engine, which was very responsive and very precise. These are the two flights I remember, who were at turn some real sensations.
I think there's sort of an interesting addition to that story, sort of a secret that you've had, but you actually filed a flight plan. At the conclusion of that flight, you filed a flight plan in case Pompidou wanted to take President Nixon in the Concorde back to Washington. So you all actually filed a flight plan in Concorde from the Azores to Washington.
A small addition for this approach for the return flight, well, it was me who was on the left and Jean Franqui who was on the right, and we were ready to set off while waiting for President Pompidou when we saw President Nixon coming with a long stride towards his Air Force One. But when he passed by Concorde, he stopped. He came to see us. See, there was still the ladder, so that was there. He got on the plane. He came into the cockpit to greet us. At the time, I believe the Senate had stopped the Boeing B-2707 program, Concorde's supersonic competitor. And so after greeting us, Nixon said, you're right. You are right. And I'll also like to say a little thing, so on the slide, we're thinking that basically maybe our President Pompidou could offer the last trip to Washington to President Nixon. We had prepared a Concorde flight plane between Lares and Washington. Well, that's our little story.
Of course, what we do at Embry-Riddle Aeronautical University is we are a university. We provide education for students to get a bachelor's degree, a master's, even a PhD. You decided in your late 70s that you wanted to pursue a PhD. In fact, you completed it at age 81. What What made you do that? Were you bored? Did you decide that there were things you really wanted more answers for? What was behind that?
When I retired, I was annoyed that I hadn't found solutions on this subject. And then, in fact, one day when I was a little irritated to see that the research couldn't agree on what to do, I decided to go for it myself, so that it would have some influence in the academic world. And in the other, I decided to embark on a doctoral thesis. So it was hard, because going from an engineering way of thinking to a researcher's way of thinking, and that's good anyway, I got out of it anyway, and so I defended my thesis in 2011, on June 30th, 2011, with a theme that was the treatment of unexpected situations of extreme urgency in flight with a cognitive model test with an expert pilot. And then, as it was in French, I thought we could also put it in English, and I had one book published called Facing the Unexpected in Flight, which was published in 2015 by Taylor and Francis. So all I can say is what I've seen myself through experience. You have to see ambition, and above all, set yourself a goal. Then you have to work and work to get it. And above all, without ever getting discouraged.
Jean, I want to thank you for being with us today. This is a great video interview that we've had with you, but also for our viewers, I want them to know that I went to France. I was in France. I visited you, spent a day with you in Toulouse. We had a special treat of spending time in the very last Concorde that you flew, that's now in a museum. And you and I sat in the cockpit, we walked around it. So for our readers' viewing pleasure, we're going to show some of those clips. But meanwhile, thank you so much for all you've done for aviation, for what you've done to promote aviation safety. So I wish you well, and Godspeed.
Go into the cockpit.
Okay.
And go to the left seat.
No, sir, you're the only one that can take the left seat.
You take the,
How does it feel to be back at home?
well, anyway, it doesn't work.
Yeah, it doesn't work. Yes, yes.
Unfortunately. But when you are seated and at the right place in the cockpit, everything is under your sight, and everything is under your hand, and it's very comfortable.
So this switch right here, this is how you raise the nose. Is that correct?
Yes, that's right.
You wear a helmet when you flew it.
Yes.
Was there an escape slide?
It was supposed just to be so an emergency exit, but we preferred not to use it.